Okay, we're going to start off with just a bit of a review of what you've learned in chemistry. Luckily, chemistry is not that far in your past, so some of this should be really familiar to you. We're going to start by talking about charges, because in this unit, we're going to follow the charges. We want to look at charged objects. So what makes an object charged? Well, first of all, we've got protons, and they are the positive charges. Where do we find them? In the nucleus. Anyone know why there's this statement here, they cannot move? We don't move them. Yeah, the element itself has a classification of hydrogen or helium or oxygen because of the number of protons. And what happens if you were to split that nucleus? You were to take some of those protons out. Yeah, you get a big bomb, big explosion, nuclear explosion. And we're going to do labs with this stuff in here, and we're not going to have any nuclear explosions in the classroom, so we can't move the protons. Okay? So not only do we not want to move them in this classroom, but in other labs, you don't move protons. So they stay put. Good? That means we're going to follow the electrons. An electron is a negative charge. They are surrounding the nucleus, so they're outside the nucleus. And if you remember back in chemistry, there was a group of electrons that were movable. They were in the outer shell, right? And we call them, do you want to remember? It starts with a V. Valence electrons. And so those are the electrons that we're really going to be following. We're not going to spend as much time as you did in chemistry with how many valence electrons there are in each different atom. But know that that's what we're talking about. We're moving valence electrons around. So these can move freely. In some types of materials, they can move from atom to atom. In other types of materials, we can give them to the atom, but they can't move from atom to atom, and we'll look at that. So just like we were talking a moment ago, the charge amount is the same. For both protons and electrons. So an electron and a proton both have the same charge amount, which means an electron plus a proton, if I just add those two charges together, I would get 0 because they're the same amount. I'm just taking one number and subtracting it. If electrons are the things that can move, then those are what we're going to follow. Why do we follow them? Because charge is conserved. You can't just suddenly get rid of an electron. So if I have an electron at the beginning, I will have that same electron in the end. It just has moved spots. It will move from one material to another, but it's still there. So just like conservation of momentum, conservation of energy, we have conservation of charge. Whatever you have at the beginning, you have that same amount at the end. Maybe it's just changed positions. Why might it change positions? Why might an electron go from one material to another or go from one side of a material to another side? It's because of forces. We know that opposites attract. What do they mean when we say opposites attract? What specifically are opposite objects that are attracting? So the protons and an electron would be opposites. They like to come towards one another. Likes repel. Well, what would be an example of likes that would be repelling in this unit? Two protons. So a positive proton and a positive proton. They would be repelling. They try to go as far away from one another as they can. Protons don't really have the ability to move away from one another too easily because they're held within the nucleus, within the atom. But they could still apply forces. So even though they couldn't move, they would apply a repulsive force. Electrons and electrons would also repel. And electrons, if they are on a conductive material, will definitely be able to zoom away from one another. And they could leave the atom. So they could go visiting other atoms because of that force. Two materials that we're looking at in here are insulators and conductors. So the first type of material would be an insulator. This is a piece of styrofoam. What do we use this for? We put it in our walls before you put your drywall over the wall, so against the stud. And why would we want to put this styrofoam stuff in our walls? What would be the point? Insulated. What does it do? Insulate. Okay, keeps heat inside your house on cold days, or it keeps heat outside your house on warm days. So that's what an insulator does. It also keeps sound from going from one room to another. So it insulates, doesn't allow sound to travel through, it doesn't allow energy to travel through. Does it allow charges to travel through it? No, it doesn't. So can I charge this piece of styrofoam? Yeah, I can give it a charge. But what does that mean? It means I can, what do I move? Electrons or protons? I move electrons. So I can add electrons to this piece of insulating material, this piece of styrofoam. But those electrons cannot move around on the surface. So I can put electrons there, or I can take electrons from it. But the electron can't go visiting from one atom over here all the way to another atom over here, because an insulative material doesn't allow charges, energy, sound to travel through it, to travel from one spot to another spot on it. Okay? So an insulator doesn't allow charges to move, and that's a really important characteristic that you're going to have to remember a lot in this unit. The other type of material that we're dealing with is a conductor. So think metal. So I've got my metal sphere here. This surface is conductive. If it's a conductor, does it allow energy to flow across it? Yeah, it does. So it also allows charges to move from one side of the material over to here. So it says here it allows charges to flow. And why would they flow across it? There's a force acting on it. If there's a proton on this side and an electron over here, there's an attractive force. So what's the electron going to do? It's going to be pulled towards the proton. If there's electrons on on here, what are they going to do? They're going to try to move as far apart from one another as they can. So they're going to flow across this material until they're as far apart as they can get. There's as much space between them because electrons have that repulsive force between them. There are questions so far?